Hey guys, welcome again to the Maths Club. If you are just joining us, you're welcome. We're continuing on plane geometry, and in this video we're looking at angles and triangle properties. So before we get on with it, if you're not subscribed to our channel, please do, and don't forget to like the video, and if you have any question, please drop it as a comment. We'll respond to all comments as soon as possible. First of all, looking at the two triangle theorems and the proof of those theorems. Then we'll look at congruent triangles, similar triangles, and of course some examples. The first triangle theorem states that the sum of angles in a triangle is 180 degrees. So if we have this triangle, we could say that the angle at A here, angle at B, angle at C, by the time you sum up all those angles, it will give you 180 degrees. Don't take my word for it. Let's see the proof. So if these are a triangle, permits me to draw a line that will be, let me just draw it somewhere here. Okay, so this line here is going to be parallel to this line. So if this guy is, if I use one arrow, I'll use one arrow here. So they're both parallel lines. And if you remember what we did when we treated lines and angles, so if you look at, this is a Z, right? This is Z. Remember what I said? Yes, great. So if this angle is angle B, this angle here would also be angle B. So let me just see, let me just refresh. So this is A, this B, this C. So if this angle here is B, this place here will be B because of what? So we say alternate angles, right? Remember, this line here is your line of transversal. Also too, if you look at this too, this you can find the Z here too, although it's a inverted Z or a mirrored Z, but you can find your Z too. This line is also a line of transversal, a transversal line. And this guy is C. This guy also would be C. Do you agree with that? Great. And what do we see about angles on a straight line? We say sum of angles on a straight line equals 180 degrees. So if you look at this, my angle B plus my angle A plus my angle C should equal 180 degrees. Why? Because sum of angles on a straight line equals 180 degrees. So this is the reason. And if that is the case, that means my angle A plus my angle B plus my angle C should also equal 180 degrees. Simple and short. So given that, we know that our angle at A plus our angle at B plus our angle at C equals 180 degrees. Sometimes when we be asked to prove these theorems in your exam, right? I mean, when you're drawing that line, you state it to say we want to draw a parallel line to BC across A, and then you say, oh, alternate angle. I mean, give the reason why you're saying this guy is equal to that guy from that picture. You have to give every reason. If you don't give the reasons, they'll assume that you just guessed or you don't know what you're saying. Triangle theorem 2 states that the exterior angle of a triangle is equal to the sum of the two interior opposite angles. We've seen this before. I've actually proved this in 2 videos to this, right? But we're going to do it again. So what he's saying is that this external angle C is equal to A plus B. But let's see. So we've proved that the sum of angles in a triangle is 180 degrees, right? So if I have A and I have B and I'm trying to find this guy, let's call it a D, right? We can see A plus B plus D is equal to 180 degrees, right? So our D will be equal to 180 minus A minus B, right? Great. Because here we said sum of angles in a triangle, right, equals 180 degrees. This was our justification. Now that we also know that, we also know something. So look at this D, this C, D and C. So what can you see from there? Great. So if I had C plus D, it also gave me 180 degrees. Why? Because the sum of angles, so it's going to be sum. So sum of angles on a straight line equals 180 degrees, right? So we talked about that. So I can replace. So if this is my equation 1 and this is my equation 2, so I'll say substitute 1 in 2, right? So anywhere I see D, I'll put 180 minus A minus B. So this will be C plus open brackets 180 minus A minus B is equal to 180 degrees, right? So let me open the bracket. Fortunately it's plus, so all the signs will still remain, but if it was like minus, these signs will change. So I have C plus 180 minus A minus B is equal to 180 degrees, right? So let's make C stand alone. So C will be equal to 180, this plus 180 will convert it to become minus 180, this minus A will convert it to become plus A, this minus B will convert it to become plus B. So 180 minus 180, that will give me 0. So my C is, I'm just left with A plus B. So we can see that by this little proof, our angle C is equal to the sum of A plus B. This proves the external angle theorem. Great. Congruent triangles. When you hear the word congruent, it just means something is identical in shape and size. So if we take two things that are exactly the same thing in terms of shape and in terms of size, we're talking about something that is congruent. In that same manner, we can say that congruent triangles are triangles that are identical in shape and size. This means that all corresponding sides and angles of the triangles are equal. Think of the word corresponding. It has to be corresponding. So corresponding sides and angles of the triangles are equal. How can we identify when two triangles are congruent? There are some, people that have done this mathematics before us, right? They've taken a lot of measurements and dimensions, and they found out that to identify triangles that are congruent, we can find them either using side congruence, side angle side congruence, angle side angle congruence, angle side congruence. So this might be a lot, but there's a shortcut that I use. So you know the word sassy, right? When somebody's sassy, when you say that is sassy, what does it mean? You can check dictionary if you know what sassy means. S-A-S-S-Y, I think so. Right, so I'm going to take note of the word sass from it. So I'll write my S here, I'll write my A here, I'll write my S on the same line of the A, and then I'll write my S at the end. So sass. For the first one, I know that all the three values are S, 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 so side. But from the second one down, anywhere I see an A, I surround with an S. Anywhere I see an S, I surround with an A. It's just a short form for you to know. So side, right? So this is an S, angle, and this is an S, angle. So this way, you can decide to do your own, how you'll be able to remember it. But it's always good to remember it because it can come out in the exam question. I can assure it has come out before and it can come out in your own. So let's look at what each of these guys mean. So for the side congruence, it means that if 3 sides of one triangle are equal to the 3 sides of another triangle, then the triangles are congruent. So if the 3 sides are equal in terms of length to the 3 sides of the other one, of course the triangles are congruent. Therefore, you also say that all corresponding angle pairs are equal. By the time if you have time, you can construct some things and you see that if 3 sides of 2 triangles are equal to each other, so one side, on that side, last side, and the last side, all the corresponding angle pairs are equal. So you have something like this. You can see AC is similar as XZ, AB is similar as XY, BC is similar as YZ. Right, so you can see that because of this, we know that all the corresponding angles, so the angles between this guy with 1 and 2, which is angle X, will be the same thing as the guy with this 1 and 2, which is angle A. The angle between these 2 and 3 marks, which is angle B, will be the same thing as the angle between these 2 and 3 marks, which is angle Y. And the angle between this guy and this guy, right, which is angle C, will be the same thing as the angle between this guy and this guy, which is angle Z. You can see that. So just by this one, that all these 2 triangles are identical in shape and size. Second is side angle side congruence. So if 2 sides are the common angle, sometimes you might hear some books say included angle, same thing, of one triangle equal to the 2 sides and the common angle of another triangle. What do I mean by common angle or included angle? So look at this. This length of AB and this length of AC. The common angle is the angle between AB and AC. So this side angle side, right? So if this guy is the same thing as, see, this AB is the same thing as RT, AC is the same thing as RS, and also the common angle A is the same thing as the common angle as angle R, right? So 3 things to check. One side goes to one side, the other side goes to the other side, and then the angle between those 2 sides are equal. So if that is the case, we can say for sure that these two triangles are congruent. And it makes sense. It makes sense if you look at this really, because where this guy will end and where this guy will end when they join, since they have the same angular parts, since they're the same angular parts, of course the length of this side will be the length of this side. So you can see, I mean, it's just some things you have to know. So we know that AB is equal to RT, AC is equal to RS, and angle A is equal to angle R. So the three checks, so those three checks check the two triangles are exact in both size and shape. Next one is angle side angle. So just like we had side angle side, you know that this one, the side is in between these two angles, right? So if two angles and the common side of one triangle are equal to the two angles at the common side of another triangle, then the triangles are congruent. So you have something like this. You have an angle here, you have an angle here, right? And then this guy here. So if this is, I mean, these two guys don't have to necessarily be the same. These two guys don't have to necessarily be the same. But if this guy is equal to this guy and this guy is equal to this guy, and the length of side between them, like this guy, is equal to this guy, you can see for sure that these two guys are exact in shape and size, or you can see they are congruent. So angle B must equal angle E. Whatever the angle is at this B must equal whatever the angle is at this E. Whatever the angle is at this C, I don't care if it's the same or is it something else, it must equal whatever is the angle at F, and the length BC must equal the length EF. So if those three conditions are met, we can say these two guys are congruent. The last is angle side. So you can see that this side is not common to the two angles, right? So two angles and a non-common side of a triangle are equal to the two angles and the corresponding, taking to the word corresponding non-common side of another triangle, then the triangles are congruent. So look at this diagram. We have this guy, then this guy here. So you can see this guy, and this guy here. You see that the side we're talking about was on the line of this guy at C with two curves, right? If it was somewhere here, let me see, if it was somewhere here, it is not, you cannot be able to see it, because we said the two angles must be equal and the corresponding non-common side. So if it's here, it must also be here, must be on the line of the two arcs. If it is on the line of this one arc, if it was here, it must also be on the line of the one arc here. So this is what we mean by angle side congruence. So if these three checks, you know that the two triangles are congruent. Angle B is equal to angle Y, whatever the value of angle C is equal to whatever the value of angle Z is, and length AC is equal to XZ. Congruent. So why is it important? It really helps you to understand how to match sides and angles correctly. I mean, there are games that they do now where they say stack some triangles together. I mean, if you already have an insight of congruence, you should be able to do that easily. And of course, this skill is used for solving geometry problems. And it also helps you understand similar triangles, which will be the next one we're talking about. So we're talking about 4 ways of knowing if a triangle is congruent. If the length of the 3 sides are equal, if the length of 2 sides are equal, and then an angle between those 2 sides are equal, right? So, I mean, same sides and the same angles in the 2 triangles, if they're equal, the same angle, right? The angle must be in between those sides, so you know that it's a congruent triangle. Or if you have 2 angles and the side between them are equal to the 2 angles and the side between them in the second triangle, then you know that those 2 of them are congruent. And if you have an angle and a corresponding side, in both cases, if they are the same, you know that these guys are congruent. So that's where the SAS comes in. And just to remind us what the SAS is, so we say our S, our A, our S, our S. So side, wherever we see A, we'll put S around it. Wherever we see S, we'll put A around it. So this S, S, this A, and this A, S. So side, common angle, side, angle, common side, angle, non-common side. Please be very careful when you see options like this. Take note of the word common, or you can see included sometimes. Please take note of these words. If they say if a side and another side and another angle, you know that is something else. What's saying is side, common angle, included angle, and side. Please take note of these words. They are very, very keywords. Similar triangles. When you hear the word similar, what does that bring to mind? So 2 things that are almost alike, right? Almost alike. Do they have to be exact? No, right? They just have to be, sometimes you can see a child and you say, this is this person's son, even though the child might be 5-year-old and his father might be 50-year-old. So this is this person's son, probably by the hairline, by the chin, by the face, you know that, oh, these two, they are similar. And you could have twins. There's some twins that they're the same height, the same. I mean, they're equal, almost equal in terms of, but when you talk about similar triangles, they don't have to necessarily be the same size in terms of length, right? But one is like a smaller version of the other, mini-me. So similar triangles are triangles that have the exact same shape but can be different in size. Unlike congruent triangles, they must be the same size. So similar triangles don't have to be exactly the same. They just have to have the same angles and sides, and those sides just have to be the same proportion. Like, oh, my daddy is 2 times my size, right? So I'm comparing my size and my dad's size, and we already have the same features. We are both shaped in the same angles, right? So we share the same angles in terms of face, in terms of every other feature. Unlike congruent triangles, which are exactly alike. One similar triangle is actually a scaled version, either it's an enlargement or a reduction of the other. And corresponding angles are equal, while corresponding sides are in the same ratio. Very, very important. To drive from this point, look at these two guys. This is smaller than this, right? But they share the same angle. This angle here is x, this angle here is x. This angle here is y, this angle here is y, this angle here is z, this angle here is z. So if this guy is, let's say this guy is 8, this guy is 10, and this guy is 6, the corresponding side must be a factor. So between y and z, you can see that the length is 6. So this guy is smaller. Let's say he's smaller by a factor of 2. This guy will be 3. So yz, this 6, this 3. This is xy is 8, right? Because it's a factor of 2. Xy here will be 4. You can see xz here is 10, but xz here would be 5, because this guy is half of the other guy. Do you get? But you can see that the corresponding sides, they have the same ratio. They're in the same ratio. So 6 divided by 3 is 2, 8 divided by 4 is 2, 10 divided by 5 is 2. So 2 from this guy, 2 from this guy, 2 from this guy. That's what they mean. So the symbol for similar triangles is the tilde. When you see this, it's called tilde. I don't know if I'm pronouncing it right, but it's tilde. So you can see our triangles again, and you can take the side ratio. So between y and z, the length is a. So y and z of this one is p, so a over p. That will have given you 2 in my case, right? In the example I did. X and y, this guy is c. X and y, this guy is r. So c over r is also give you 2 in the case of the example that I used. xz, this is b. xz, this is q. So b over q would have given you 2 also. So it says that if 2 triangles are similar, their area ratio is the square of the side ratio. Their area ratio is the square of the side ratio. So let's see. If we want to find the area ratio, what is that saying? So it's just saying the area of triangle 1, which is this guy, all over the area of triangle 2 is the side ratio raised to the power of 2. So let's say I use this guy and I use this guy. So that's 6 divided by 3 all squared. So this guy will be 2 squared and this guy will be 4. So the area ratio is 4 in this case. If we do the area calculation of this, find out that the area of this guy is 24. Let's assume these are all centimeter, this centimeter, this centimeter, this centimeter, this centimeter, this centimeter. So 24 centimeter squared, right? Because of that, because I know that the area ratio of this guy is 4, I can say, oh, 4 is equal to the area of the first guy, which is 24 all over 82, and the cross multiply, that will give me 482 is equal to 24, and if I divide both sides by 4, the area of the second guy, so the 82 is equal to 6 centimeters squared. That was telling me that the area ratio is the square of the side ratio. Now let's prove that this guy is actually 6. So we know that the area is equal to square root of s multiplying s minus a, s minus b, s minus c, right? And we said s is equal to a plus b plus c all over 2, right? So these, let's see, so this 3 plus 4 plus 5. We've talked about this in a video talking about of triangles, so I'm not going to talk about that. So this is 7 plus 5, which is 12, 12 divided by 2, which is 6. So now let's see. So that will be square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5 in brackets. So this square root of 6 times 3 times 2 times 1. So this square root of 6 times 3 is 18, 18 times 2 is 36. So square root of 36 is what? 6 centimeter squared. So you can see that instead of you going through all of this, if they told you that 2 triangles are similar and they've given you the length of any of the corresponding sides, they don't have to give you the 2. They can just give maybe this guy and this guy, or this guy and this guy, or this guy and this guy, and they tell that the area of one of them is so and so. Find the area of the other. That's a question like that can come. You should already know that you can find the area ratio by squaring the side ratio. And once you know the area ratio, you can now plug it in and find the area of the other triangle. So this is just to actually make you start thinking. Please go and look for questions that have something like this. So we're back, and we were told that the area ratio is, you can say, a over p squared, which is sometimes b over q squared, which is sometimes c over r squared. You know, I said the symbol of similar triangles is the tilde sign. So you can see these are like common representations of similar triangles. So you can see that this guy, right? This, let me just say, this is one triangle. This small guy. Let me draw it so you can see it very well. This is one triangle, right? And you can see the bigger guy is the second triangle. So now that we know that this guy here, PS, is similar to PR in this bigger one. So the length of PS all over the length of PR will give us the side ratio. The length of PT, this 2, over the length of PQ, you can see this 2. PT over PQ will give us this guy. And finally, the length of ST, which is this guy, all over the length of QR. You can see similar. This is 1, 2. You can see 1, 2. Same thing. This will give you the side ratio. Also, too, when you see something like this, you know that these two guys are similar. Why? We've talked about transversal, parallel lines, and all of that. If this guy makes an angle, let's say this is the angle he makes with these two guys, right? This parallel line makes an angle with this, it will be the same thing, right? Because of corresponding angles. Remember we talked about that. Also, too, if you make the same angle with this guy, yeah, it will also make the same angle with this guy here. So if you mix an angle this with this guy, it's the same angle this guy because of corresponding angles. And of course they share this last guy. So they share this last guy. So we can say that these two guys are similar triangles. So of course we could say that MQ all over MN, you can see 1, 2 all over MN would be equal to MH, you can say MH all over MO, and also QH all over NO. We didn't put that, but that should be there. So QH all over NO will also give you this side ratio. Also look at this guy too. You can see this is a parallel line, this is a parallel line, this is a transversal line, this is a transversal line. You can see this guy, you can see that Z. So you can see top left would equal bottom right. And you can also see this Z too in this guy here. See the Z is a mirrored Z, right? So we say top right will equal bottom left. And from this guy, can you remember this guy? We said vertically opposite angles are equal. So this guy will also equal this guy. So you can see that this guy is the same as this guy, this guy is the same as this guy, this guy is the same as this guy. So you can see a classic example of similar triangles. A smaller guy and a bigger guy, but they share the same angles. So what can we say? AB 2, 3, right? 2, 3 all over DE will be the side ratio, and AC, this is 1, 2 all over CD. See, this 1, 2, yeah, AC all over CD, and also BC 1 3, BC. I'm using 1 3. I'm not just saying that because this angle is equal to this angle, right? I'm looking for the ones that have similar angles. So BC all over CE. So this 1 3. So BC all over CE, and you get your side ratio. So basically, when I say, once again, when I say 1 2 3, I'm just trying to say that, oh, this is the same thing as this, this is the same thing as this, this is the same thing as this. Or if it was a real question, I'll be giving maybe 30 degrees, 30 degrees, 90 degrees, something like that. Now look at this guy too. You also can also see something like this. You know that already this is a similar triangle question. So you can see that this is a parallel line, this is a parallel line, this is a transversal line between those two parallel lines, which also goes up. So whatever angle we make to this guy, it's make with this guy. Whatever angles we make with this guy, it's make with this guy, because of what? Corresponding angles, and they both share this guy. So you can see that the triangle PQT is similar to triangle PRS. Yeah, the triangle ABC is similar to the triangle CDE. So whenever I see shapes like this, just know that I'm dealing with a similar triangle question. So also PT all over PS is equal to PQ all over PR. So you can say corresponding side, you know, the corresponding side, and then CQ all over SR give you the side ratio. Question 1 states that in the diagram, the triangle HKL and HIJ are similar. Let's see the triangles. Right, so these HKL and HIJ, they told us that they are similar triangles. Which of the following ratios is equal to LH, like the length of LH all over the length of JH? So length of LH, so you can see x degrees LH, JH, you can see the x degree too. Great. So which of them is similar to that? So we have different options, but I know that this guy here and this guy here, they should be the same side ratio. They should give us the same side ratio as LH all over JH. So because this is like the, how do you call it, the base, this is like the base. So let's see if there will be KL all over JI, and that's option A. So KL over JI. Let's see the other options just to be sure. That's our answer. But let's see the other options. So this is HK. HK. If it was HK, it should have been HK all over HI. Right? HK. These opposites on the same side, the opposites of this guy. So this HK. So this is the opposite of this guy. So that will be HI. But see, this HK over JK, which does not make any sense. This JI all over KL. See, this is the base, this is the base. But why is it not C? Because look at this guy here. This is LH. LH is from the smaller one. So the small length all over JH, see JH all over the big length. But this one is saying JI big length all over KL, which is small length. So you can see this would be like, so if this guy was giving me 2, if this normal guy was giving me 2, this one will give me 1 over 2. And this guy, this is HK. See this guy, HK, so the length opposite this guy, HK all over. If it was HK, it should have been HI, because it's opposite this guy, so HI. That would be HK all over HI. But look at what they had, HK all over LK, which did not make any sense. I hope you understand why I actually had to go through all of this, because it's very important that you understand what similar triangles and congruent triangles are. So answer is option A. Great. Question also that in the diagram, this diagram, so you can see that both, once it's shown that they're talking about similar triangles. SQ is 4 centimeter, PT is 7 centimeter, TR is 5 centimeter, ST is parallel to, oh, okay, this should have been QR, not OR, so it's parallel to QR. And also says if SP is X centimeter, find the value of X. Write 2009. I want you to pause the video and try this out yourself. So from this, I know that the side ratio is equal to, let me see, great. So I could, I mean, this, there's no angle, but I already know that what I see is what I get. So this 7, right? So this 7 all over, 7 from the small triangle all over the length of this big side, that will be 7 plus 5 would equal to X, the length of the small side, all over the length of the entire side from the big triangle, that will be X plus 4. So that will be 7 over 12 is equal to x all over x plus 4. So if I cross multiply, this will give me 12x is equal to 7 open bracket x plus 4. So this 12x is equal to 7x plus 28. So 12x minus 7x is equal to 28. 5x is equal to 28. And if I divide both sides by 5, my x would be equal to, this will give me 5.6 centimeter. So our x is 5.6 centimeter. Let's see if we're correct. That will be option A. Great. Although it has meant to have been okay, so they said SP is x centimeters. So those find x. I mean, I'll have queried them. Why did not give us the units? They've given us the units here already. Question 3 says that which of the following is not a sufficient condition for two triangles to be congruent? WAEC 2020. See how recent it is. You can see what we have here. So we remember that our shortcut. So SAS, right? So said the first guy, you put S everywhere from here downwards, and when you see A, you put S around it, and when you see S, you put A around it, and when you see S also, you put A around it, right? So SSS, it is not this guy. AAS, it is not this guy. SAS, it's not this guy. SSA, of course, these are answer, right? Remember, another way to remember it is, yeah, the angle is in between the sides, yeah, the side is in between the angles, and this last one, the side is at the end of, right? It's not common, it's not in between anything, it's just towards the end. So our answer is option D. Correct. Question 4 says that in the diagram above, I guess in this case is below, yeah, AB is 12 centimeter, AE is 8 centimeter, DC is 9 centimeter, and AB is parallel to DC. Calculate EC. This is from WAEC 1995. I want you to pause the video and try this out yourself. So this is what we have. We're told that AB is 12 centimeter, AE is 8 centimeter, DC is 9 centimeter, and we're told to find this guy. Let's call it X. So from our side ratio, right, I mean, this side is this side. So I could just say small over big or big over small, anyone. So let me say big over small. So that's 12 over 9 is equal to, so big all over small. So this one triangle on its own, this and that triangle on its own. So it's not like those other ones where maybe they were sharing the vertex or something. No. So we said big over small. So the length of this big side is 8. So it's 8 all over. The length of this small side is X. So let me just simplify. If I cross multiply 3 here 4, 3 here 3. So when I cross multiply, this will give me 4x is equal to 8 times 3. And divide both sides by 4. 4 here 2. 4 will cancel. Yeah, so our x is equal to 2 times 3, which is 6. So 6 centimeters. So our value of EC is 6 centimeters. That will be option E. Question 5 says that in the diagram, angle PMN, so you can see PMN is equal to angle PR cubed. You can see it's 1, 1. PNM 2 is equal to PQR, so PQR 2, so that two of them are equal. If PM is 3, MQ is 7, PN is 5, find NR. Let's take it from WAEC 1996. Pause the video and try this out yourself. So we have this. So what is the side ratio? Here we have the top and this guy, right? The length of this guy is 3 all over. So top and 1, so top and 1, right? So we're trying to find NR. Let's call this X. So that would be 5 plus X, right? So I'm saying the length of the small side all over the length of the big corresponding side. Remember I said the corresponding side. So by the time you add this, so that will be 5 plus X is equal to, let's take this guy, so small, right? So top and 2 arcs, so that would be 5 all over top and 2 arcs. That was the entire length here. That would be 7 plus 3, which is 10. Unlike that previous question, you can start these two triangles, they share the same vertex, they share the same top. So when you're doing, you have to add, but those ones, they were separate, right? So you just need to know those things. So if you cross multiply, this will give you 3 times 10 is equal to 5 times 5 plus X, and 3 times 10 is 30, 5 times 5 is 25, 5 times x is plus 5x. So let's collect them. So that will be 5x is equal to 30 minus 25. 5x is equal to 5, and divided by 5, our x is equal to 1 centimeter. So the length of NR is 1 centimeter. Let's see if we're correct. That will be option A. Correct. Question 6 now says that the ratio of the areas of similar triangles is necessarily equal to, this from JAMB 1980, that you can do a chorus answer, is necessarily equal to what? Beautiful, the square of the side ratio. So let's see, ratio of the corresponding sides, no. Ratio of the squares of the corresponding side, yes. We don't need to even look at that. That is our answer. Option B. Correct. So with this, we've come to the end of this particular video. Please watch it and ensure you understand congruent and similar triangles before you move on to the WAEC past question on this. I would see you guys in the next video. Once again, if you have not subscribed to our channel, please do. And our channel is youtube.com/@themathsclub, MATHS, the Maths Club together. I'll see you guys in the next video. Bye for now.